All right, how's everybody doing today? We're going to be talking about the Cartesian plane, or our coordinate axes, where we have graphed equations in the past. And recall x1 represents one value of our independent variable, y1 represents one value of our dependent variable. We usually use x and y for those. Now, we're going to consider, of course, hopefully we all recall how to find the point 1, 3 on the plane. And that plane, of course, is typical. This is a small piece of it. And we have the point 1 and up 3. So that's our point there. But what should be the distances there? So how about the distance? Let's start with simple. 0, 2, and 0, 0. And this seems almost silly. 0, 0, 0, 2. And that distance, of course, it's all in a straight line. That seems easy to be. We know that should be 2. Right? How about, however, if we want to go from 0, 0 to 2, 3? And there we're looking for this distance. And now we have base is 2, 3, and hopefully recall we use this Pythagorean identity here, Pythagorean theorem. And we get that our distance, after taking the square root of both sides, is the square root of 2 squared plus 3 squared. Notice here, I don't put a negative sign in front of the square root, even though normally when we take the square root, we do take plus or minus, but that's because we know the distance has to be positive by definition. So, and if I calculate this is the square root of 13, irrational number. That's the best way to write it. Any calculator doesn't exactly know what it is. All right, so now the last is what's between two general points. All right, so something like finding the distance between 1, 2, and 4, 6. Well, here, let's see, 1 and 2, and then 4, and oh, I went a little short, but that's okay, because in math, it doesn't have to be perfect, no matter what they told you. All right, so here, well, it looks like we, again, have our triangle. We're looking for this distance. And here, what do we got for the sides? Oh, this says 4 minus 1, which is 3. This says 6 minus 2, which is 4. All right, and that's going to tell me that my distance equals square root of 4 minus 1, quantity squared, plus 6 minus 2, quantity squared. This is the square root of 3 squared plus 4 squared, of course. And this turns out to be 5. Square root of 25 is 5. Again, we want the positive number here. Any carpenter would know. Of course, that's the way we make things squares, a nice 3, 4, 5 triangle. But this looks like it gives us our distance formula in general. Difference, the square root of the difference of the x's squared plus the difference of the y squared. But all under the square root. Let's be clear about that. And we can see our distance formula right here. Again, it's the distance of the difference of the x's squared plus the differences of y squared, and you take the square root of the whole thing. And for an exercise, I'll leave you an exercise. I want you to find the distance between 2, -1, and 3, 4. All right, let me know if you have any questions. Have a great day.